I would like to say good morning to everyone that's on the line. Hopefully, wow, it's a pretty full audience today. So I'm Janelle Disciplino with the Mid-Atlantic Geospatial Transportation Users Group, and I'd like to welcome you to the MAGTUG webinar entitled CAD to GIS Integration. Thank you for being with us today. Just a little housekeeping before we start. This webinar is made possible by JMT Technology Group, a progressive geospatial and information and technology services provider specializing in transportation application solutions. We thank JMT for the use of their WebEx account. Please note that this webinar is being recorded and will be available on the magtug.wordpress.com website shortly after today's event. Please visit our website for more information and to register for upcoming events like the Open Source GIS and Open Data Symposium that will be held on May 25th and is being co-sponsored by the Mid-Atlantic chapter of the Urban and Regional Information Systems Association, or MAC-URISA for short. We hope that you'll participate in today's webinar by typing in questions you have for our presenters into the Q&A box on the bottom right of the WebEx screen. I or Bob will read your questions at the end of the webinar to the so that the presenters can answer them. And now it's my pleasure to introduce Eric Rodenberg, Solution Engineer with the Esri Transportation Team. And I'm not sure if Jason Seeley is on the line, but he's the Mid-Atlantic Regional Account Manager, also with ESRI, that's made this possible today. Eric will be exploring the integration of AutoCAD with ArcGIS to support better decision-making. Eric, the virtual floor is yours. Thank you.
Thank you. All right. So about 5 months ago, I was asked by colleagues, and we've been exploring this idea of a CAD to GIS life cycle. And there is indeed a life cycle that is generally pretty standard that almost all organizations use or would like to use in order to convert CAD data to GIS. We are going to explore what that workflow looks like, and we're going to explore some of the problems and issues that CAD to GIS integration presents. I also plan to spend a little bit of time just going over the solutions that I put together to help make this process possible in terms of bringing CAD over to GIS. So as part of the transportation practice at Esri, I work with all 50 state DOTs, and I've recently been working a lot with local cities and counties as well from the addressing and LRS perspective. So I've been doing a lot of work with roads and highways, educating the locals on what roads and highways can do for them. And this topic of CAD integration comes up quite a bit. In fact, GIST was last week. GIST is the big transportation conference sponsored by AASHTO, and that was in Raleigh, North Carolina last week. And every year they do a roll call where every state DOT stands up and talks about what they're working on for the upcoming year. And almost every single state brought up this idea of CAD integration. So it's a hot topic, and judging by the number of attendees today, it's obviously a hot topic for you as well. So I want to walk you through some of the challenges. Then I'm going to walk you through some solutions, and then I'm going to spend a little bit of time showing you basically going through a call to action in terms of things that you can start doing, things that you can start doing with your contractors if you use contractors, or things you can do with your designers if you have CAD designers on staff. And I'm not just going to solely focus on AutoCAD, but also MicroStation as well, because the DOTs are heavy users of MicroStation. So I have to be somewhat agnostic when I deal with CAD, because we are dealing with multiple organizations that use not only AutoCAD, but Bentley and other solutions as well. So that's a little bit about how this next hour is going to go. So the 5 months ago when we undertook this project, there were really 4 things that we wanted to explore, and 4 things that kept coming up over and over again as we were talking to different state DOTs and even the locals. The first and foremost, a lot of DOTs right now are under pressure to develop these construction information models in a 3D landscape and push that out on the web. A lot of them are being asked to do this. So there is a challenge right now in understanding how to get this CAD data out of its format and into a 3D GIS format. So that's one of the things I'm going to be looking at very closely to start off this morning. Then once we have those 3D features, we obviously want to visualize that, and I want to show you what you have available to you to do that visualization. Excuse me. In addition, we, in talking with DOTs, we encountered this need for DOTs to provide a way for contractors to take the design files out in the field and mark them up, or possibly even edit them. And so I've put together a workflow that does just that using ArcGIS Online and Collector, and I'm going to show you that today. The next thing, and this is something that's a little bit longer term project because it is a little bit more complex, there is a requirement by many organizations to validate CAD files that come in to them from contractors and designers to ensure that they meet their standards. Now, I'm going to talk about that at the end. I've got to kind of set the stage here with the discussion on standards and the issues and challenges we face before we get into what we're going to be working on next. But that's a little bit about how the morning's going to go. So I'm going to jump right into CAD to 3D GIS. And to do that, I'm going to get a little help here. I'm going to recruit a little help from ArcGIS Pro. And what you're looking at is State of Alaska, and I received some CAD files from them, and as I was prototyping some tools, I developed some workflows to help extract out the 3D features that they had in their CAD files. So in this file, we're going to be jumping into an area along the Richardson Highway, which is in Valdez, Alaska. Valdez is obviously famous for the oil spill that happened in the 80s, and you're going to start to see this take shape. There are, as I zoom in. So as I zoom in some more, we're going to zoom in on that Richardson Highway, and you see this CAD file come to life. You see these 3D features. We're going to see the base map render, and of course, if I need to make changes, I can easily do that just by updating the base map and displaying on the fly a new base map. So this base map runs right along this river that feeds into the Valdez Bay. And you get a really nice picture of things that we can see. So I've taken this CAD file that they provided me, and I've extracted everything from it, everything I possibly could. They had tree data, contours, road right-of-way, edge of pavement, center lines. They even have some underground features, which I'll share with you in a minute. And of course, as you pan and zoom around, you can see things like the electrical, the electrical lines. You see the signs. I'm going to switch this back to the topo base map because I think it shows a little better. So you see the high tension power lines. That's what I was thinking of. And as we zoom again, you get this view of the trees, and you get this view of the landscape. So taking this CAD file, this design for this road expansion, I'm able to make it come to life in Pro through this scene viewer. So being able to build these scenes is powerful because then I can take those and publish those out to the web. I can publish those out as I can publish those out as videos, and then when we go to post this on the website, the public can get a real-time sense of what the particular project's going to look like that the DOT is about to undertake. And we see lots of DOTs starting to do this with other platforms, but the beauty of doing this all in GIS is that once I save these features in GIS and I make updates to those features, the updates to the web scenes are automatically pulled in and picked up because we're just making changes to features. Now, the other nice thing about this is I can easily make changes. So for instance, if I select my tree layer, you can see here, right now it's using elm trees. Well, if I wanted to change that to something more appropriate for Alaska, I can easily do that on the fly, and those trees change based on the type that I choose. So these features are really easy to manipulate and modify to get out of it what you want to see. So let's zoom in again, and let's get a bird's eye view in the trees. And of course, I can always turn these features off, and we can start to see other things. Like now you see a culvert, actually 2 culverts, running under the highway. So we see these outfalls, we see the culvert pipes, they're actually sticking out through the scene. So if I tilt up, you can see that those culverts stick out of the ground, and they show up on the other side of the road as well, underneath the contours. So now if we zoom into the road view, and we'll turn our trees back on now because they won't be in the way, we get a nice view down the road of this particular section. So I see all my high tension power lines, I see my signs, center lines, culvert outfalls. I've got everything in here. I've even got the stream data that's flowing through those culverts. And of course, the advantage of 3D is not only can I look above ground, but I can also look underground. So I have the ability to go under this surface and see those pipes actually crossing through the earth to the other side of the road, which is very powerful. You also see the underground telco. So this is telephone lines and nodes along those lines that connect from one node to another. So if I click on one of these, I can get the attributes about it, and all that information is available to me now that I've converted it out of CAD and into GIS, and I can start to expose it. And everything I've done was done using Model Builder. So not one thing was coded, not one thing was done with third-party tools. It was all done using out-of-the-box geoprocessing, and that enables me to make this possible. So I'm going to get into what that process looked like in a minute, but let's just continue on here and move through. So finally, we'll take another look underground, and we see we've got a really good idea of our geometry. We even see the stanchions for the high mass power lines. You see the stream that feeds that culvert, and you've got a really nice bird's eye view of the project. So with that, let's jump back into the slides, and I'll talk through the process I used to get to this point. So this is the end result. This is what I'm trying to achieve. So the whole purpose of this project was to get to a point where we could view this data in 2 or 3D. So I wanted to be able to have the option to switch back and forth. Because having that option is important to me, because that gives me the ability to do things like I said, publish those web scenes out on the web, edit those 2D features if I need to, and make those changes filter through no matter what way I'm looking at this data. So that was really important, being able to create and interact with not only 2D but 3D features. I'm going to show you later on how we can also collect data in the field, or possibly even just mark up a CAD file, because there are some caveats to editing CAD data with Collector. or just data in general with collector, and I want to show you that. So, so the requirements were to ensure successful CAD conversion workflow. So there are 3 challenges when we do this. The first is location, and I'm going to spend a minute showing you what that means. The next is submission standards, and the final challenge is attribution. So we'll spend a little bit of time going through all 3 of these items. So there's really 3, when you're talking about location, there's 3 ways to work with CAD data in GIS. The most common one, and the one I've probably seen the most over time, as a representative of Esri and as just working in county government where I started, this is the most common way I deal with CAD data. I get this CAD file that comes into me from someone, and it has no georeferencing. It just shows up in the middle of the Atlantic Ocean off the coast of Africa at 0.00. So what that means is that that CAD file was referenced to paper space, generally speaking. So it wasn't tied to any coordinate system. It wasn't tied to any measurement values on the Earth. It was just tied to paper space. And when we get those, we call that area of the world null island. It's not really an island. It's just generally where unreferenced GIS data and CAD data goes to when it doesn't have a home. That's the first way I typically deal with data, and that's the most challenging way, because when it comes into me, then I've got to georeference it. And generally speaking, the data I'm working with in CAD doesn't always line up with the data I'm dealing with in GIS. So you wind up doing rubber sheeting and stretching and skewing of the CAD file, and that's not always good. So, in fact, that's never good. So if I have things to tie it down to, like control points, that's always the best scenario, although that's probably the most rare. I rarely see that happen. But in the DOTs, it's fairly common for that to be the case, where they can tie these CAD files down to control. But I still have run into quite a few DOTs where that's not the case, Alaska being one. They had some of their files were not tied down, so it was a pretty big challenge at first. I have found some organizations will create a reference coordinate system. It's not a true state plane coordinate system. So this was the case in Alaska. They created this reference coordinate system of Alaska UTM, which is what they work in. And when I initially loaded the data, and in this slide here, what you're seeing is that null island. Typically, when that data comes in unreferenced, unprojected, it shows up right in this area, right in here off of the coast of Africa. But the case of the CAD data that Alaska gave me that I just showed you in Pro, it actually dropped inside of the continent of Africa. So you can see here it's near Libya, near the border of Libya and Niger and Chad. It's kind of like right at this tip where these 3 countries meet up. And it's interesting. And when I saw this, I didn't know what to make of it at first. I was a little bit confused and thrown off because I thought, okay, maybe this is referenced somehow. And when I talked to the CAD designers, and it turns out that they use this reference coordinate system. It's not the true UTM system, but it's a reference system. So I did a little digging, and it turns out that it's projected. It's just the coordinates are unknown to ArcMap when you initially load them in. So you get this data, it just drops in the middle of Africa somewhere, or somewhere on the globe. And so what I had to do, I did a little research, and it turns out when that happens, there is a best practice. There's a way to deal with that. So it turns out that in Alaska, they have 14 UTM zones that they deal with, their CAD operators. So in that case, I would build 14 folders in my file directory. And in each one of those folders, what you have to do is you have to take that projection, whatever that projection is for that zone that CAD file falls in, and you need to rename that CAD file. So in this case, I'm working with UTM Zone 7. I had to rename the UTM Zone 7 .prj file to Esri_CAD.prj. And then I had to dump it in that folder, Alaska State Plane Zone 7. Then any CAD files that fall in that zone automatically inherit that projection. So if you're not following me, what I'm doing here is I create a folder within my computer directory structure. I name it whatever the zone is for that area. So in the case of Alaska, this CAD file I was working with, I named the folder Alaska UTM Zone 7, or Zone 17. And then I took the Esri_CAD.prj, which I renamed from whatever the projection was for that zone, and I stuck it in that folder. And then all the CAD files that live in that folder automatically inherit that projection. So what I got was this. So if we zoom in, when I made that change, all of my CAD files for the state of Alaska for this particular zone just dropped right into place. Then I had the same issue come up with Colorado. I did the same exact thing, set up a folder with their different, I think they're State Plane North and South, created a State Plane North and a State Plane South folder, took a couple of the CAD files they shared with me, stuck them in that folder, and then created renamed the PRJs for Colorado State Plane North and Colorado State Plane South to Esri_CAD and stuck them in the respective folders. And when I loaded those CAD files into ArcMap, they just dropped right into place, exactly where they needed to go. So the thing we learned is that the best solution is to always have the CAD file be projected and referenced. So that means that the CAD operator has tied that CAD file into known control points. If that's done, then I can easily connect that CAD file to those same control points in GIS, because the points will be the same in GIS and CAD. They'll have the same coordinate values. I drop the CAD file in and it overlays perfectly. That's the #1 scenario. That's the scenario we always hope for. Scenario number 2 is this one, where even if it's using a reference coordinate system, as long as I create that folder structure, stick the appropriate projection files inside of that and rename them Esri_CAD, ArcGIS will know what to do with the files when I add them in the map. The least desirable is the situation where we're missing, where we aren't georeferenced and we aren't projected at all, and it drops into Null Island. Then I've got a lot of work to do, and I can't guarantee it's always going to be perfect. So what we're saying here is, when you're writing a CAD submission standard, that's what I'm telling people to ask for. Make that a requirement that they have to tie into control, or that they have to use a reference coordinate system. That way, when you go to load that file in, you're not adjusting it, skewing it, and distorting it, because that's ultimately what's going to happen if you get a file and that's missing a georeference. Now, this is a challenge for those historic files, right? If I got a file that was made, a CAD file that was created 10 years ago, it's not going to be practical. Or maybe I've got hundreds of CAD files or thousands of CAD files from 10 years ago. It's not going to be practical to go back and fix those. So we're going to have to deal with those separately on a one-on-one basis. There is unfortunately no easy button to go back and fix these. The next issue is submission standards. And this is a challenging issue as well. I ran into this with Alaska and Colorado. The naming convention is the #1 problem I find. So here I have a CAD file. It's the same one from Richardson Highway. And you can see the layer names. I'm looking at the layer names in MicroStation. And for instance, the center line is called V-drive or V-driv-CNTR. So that indicates it's the center line. So when I convert this and bring it into ArcGIS, layer name comes through perfectly. That's not the issue. The issue is when I've got another CAD file where maybe they spell center instead of CNTR, or DRIVE instead of DRIV, or some other derivation of that layer name. That's when I run into problems. Or generally, if it's missing, that's not as big a deal, but when it's a different name, that's a big deal. Because what I'm doing is I'm using queries to extract out these layers. So I've got a bunch of queries set up in my geoprocessing model that identifies the layers, the appropriate layers, and then extracts those out individually and puts those into the appropriate feature class. So I have a centerline feature class that I map this CAD layer to. And if it's different, that causes problems. So I need to know that ahead of time. And that's really where that CAD validation I talked about earlier is going to save us a lot of time, because theoretically I would be able to run it through that tool and it's going to spit out a report saying whether or not the CAD file meets my standards. So again, if you can develop a standard that says a center line is always going to be called V-DRIV-CNTR, then do it, because that's going to make it easier for you to pull out this information and get it where it needs to go, because that's really what CAD conversion is all about, is mapping data from CAD to the appropriate feature classes in ArcGIS and using the geoprocessing tools to extract it all out and get it where it needs to go. That's the biggest challenge. And the other challenge in this is that there are over 5,000 counties in the U.S. That means there's 5,000 ways that people deal with this, and there are 5,000 standards. Even in the DOTs, every state does it a little different. They all have a different standard. So that means I've got 50 standards to work with. It's not one single data model, generally speaking, although that would be nice. It's not the case. We're finding that everybody does this a little different. They have a little bit different naming convention from state to state, which I would think it would make it a difficult task for contractors as well, especially if they have to operate in multiple states. But we find that this is probably the biggest challenge next to projection. Another challenge I've seen is that CAD tends to render symbologies differently than GIS does, right? So I think you guys will understand this when you see this slide. I've got this CAD file of a sign in green here that you see on the left. This is actually constructed from 14 polylines. Now in GIS, we represent that sign as a point. Same with the light. We've got a street light that's represented as 8 polylines. That is a challenge to me, because if I want to grab that light and move it, I've got to know to grab 14 polylines. And that's not the easiest thing to do, especially in a mobile situation. That's not going to be very practical. Now I have found, and I want to show you this real quick, and I've tested this, and I can tell you that this works. I've tested it in Collector, and it works perfectly. If I select this CAD node for this sign, you see here it has a handle, IDF32. Now, if I select one of these lines, there we go, it has the same handle as that point. So I did a test back in December where I created a relationship class between the points and the lines in the CAD. So I went in and I created a relationship class specific to signs. And I used the handle as the foreign and primary key, or the primary and foreign keys, and I created a composite relationship. And for those of you who have ever dealt with things like feature-linked annotation is a great example. When you move a feature, the annotation moves with the feature. that is using a relationship class called a composite relationship. I did the same thing here. I created a composite relationship between the points and the lines in this light. And I identified out those specific layers. And when I grabbed the point and collector and moved it, all the lines moved with it when I set the point where I wanted it. It was pretty amazing. Now the trick is, while I can do this, the trick is to get it automated so that when I write this out to a file geodatabase, it automatically creates those relationships. That's the part of it I haven't worked out yet. So I will tell you that you can build these relationships right out of the box. It's really easy to do. No difficulty in doing it. I just want to automate it so I don't have to do this for 5,000 CAD files. But this would allow me in a mobile environment to move a point and all the lines move with it. Now, some layers are very inconsistent, and this gets back to standards again. Like for instance, this culvert node has a handle IDF30. The culvert itself has a completely different handle. So in this case, it wouldn't work. The relationship wouldn't work because the foreign and primary keys are different. I would have to go in and manually relate those features together, and that's going to be way too much work. So I've got to understand a little bit more about what that handle does, and if we can make it consistent between these nodes and these lines. And so far, I haven't been very successful in finding what that relationship is, but I know in some features it's the same, in others it's not. So we've got to work through that, but that's a problem for another day. So as I mentioned, in GIS, we typically render these features as points. It's the easiest way to render them, and then I can assign attributes, and then I can do relationships to things like sign posts. So if I move the post, the sign moves with the post. It stays with it. And it can be a one-to-many relationship, right? Because a sign post can have many signs attached to it. So we think about it a little differently than CAD does. Now the next challenge is attribution. Now this is less critical than the other two, but there is an enhancement effect that this can provide your organization if it's available. I have seen in some instances, and I've only seen this actually twice. I've seen this in my career. I've been with Esri 14 years, and I've worked in county government 2 years. So I've been at this for about 16 years, and I've only seen this happen twice, where a developer provided me a CAD file, and then they provided me with a companion access database that had attributes about that CAD file. So basically, in AutoCAD Map, they can create a relationship to the CAD features back to the access database using the entity ID. So with the entity ID, I can populate attributes about that feature, and then when I bring those into GIS, I can actually use that access database to basically merge those attributes in with the geometry that I pull in. So now my CAD file that was separate from the access database, it's all one now. It's all together. I've got geometry and attributes. But again, it's very rare, and it doesn't impede the ability to convert data. It just means that if I don't have those attributes, I'm not going to have a lot of data. I'm going to have to go in and populate that myself. It's like a street name or a address block range or the type of power pole it might be or the type of culvert it might be or the material. All that I would have to go in and populate after I've converted. So all of this yields this process. So taking all these challenges, I was able to create a process to get my CAD to 3D GIS. So to do this, I created a geoprocessing model. And the reason is it's a complex workflow, but the execution is really simple. I provide it with an input CAD file. I provide the model with an input CAD file, and I tell it where I want the data to go. and then the CAD file, or the model runs the job and extracts, transforms, and loads the data into a file geodatabase. And then from there I can visualize it, or I can publish it out to ArcGIS Online. So that's the goal. So that's the process in 4 very simple broken down steps. Now within the model, I'm doing 3 types of things because I'm dealing with 3 types of geometries. I'm dealing with points, I'm dealing with lines, and in some cases polygons. In the case of points, I have to identify the CAD layers and copy the 3D points to 3D point feature classes. That's the process for converting points. In the case of lines, I've got to do a little bit more work. I have to identify the CAD layers, or lines by their layer names. So like the culvert, I had to find that. I had to find the V.DRIV-CNTR to pull out the center lines and get those into a center line feature class. And I intersect those with that 3D point geometry. So I don't know if you notice here, but in this file, I've got these nodes along the center line, and every node has a 3D elevation. So when I run my process, to convert, I'm extracting out the 3D value, the 3D elevation value, and inserting it into the end of that particular line. So every endpoint of every line has an elevation. So the elevation of one end might be different than the elevation of the other. That's how in that 3D demo you saw earlier, I was able to get my culverts are able to slant downward towards the drainage point, towards the sink. So we've got a source and we've got a sink. So all the flow is coming this way down into the culvert and then out and down to the river. So I'm using those elevations from those nodes to populate the ends of those lines, and then once we have those elevations, we've got 3D lines, and we can represent those lines with the appropriate pitch. And then if I know things like the diameter of the culverts, then we can do some really crazy stuff. We can model out the culverts to their appropriate size as they would appear if you were inspecting one. So there's lots of possibilities here once you start populating that data. In the case of polygons, it's a little bit more challenging. In most cases, I have to create polygons from lines. So in the case of my right-of-ways, I had to take all my lines, run them through, and check for closure to make sure that they closed off the boundaries and the shoulders. I had to make sure all that data closed off in order to create polygons. And it's not a perfect process, by the way. In the case of building structures, those are pretty easy. I check those for closure, and if they close, then it creates polygons pretty easy. But some of the things like shoulders, road right-of-ways, edge of pavement, that's a little bit more challenging. And then I get the elevation by interpolating against the DEM. So if I have my own DEM, I can interpolate those elevations. If I could also interpolate from the contours. So I could create a surface out of the contours provided and interpolate from that as well to get a 3D poly. Polys are a challenge, though. I'm going to be upfront with you there. That's not the easiest thing in the world to work with. So this is a section of the model doing everything I described. So I've got this incoming CAD layer. I make it a feature layer in geoprocessing, and then I convert that feature, which is a virtual kind of basically an in-memory layer. I convert that in-memory feature layer to a feature class. I call it culvert lines. I do the same thing with my outfalls. My outfalls are points. Those points contain elevation, and I create this in-memory layer. I convert that to an outfall feature class, and then I intersect my culvert lines with those points to create 3D culverts. Now that I have 3D culverts, I can export those out to my final processed feature class of culverts. So I've got this process feature class of culverts, and I've got this process feature class of outfalls. And that is the process in the simplest form. So I tell it what the input CAD file points and lines are, and then it runs through this process. Now, the one thing you're not seeing is that there's about 40 other layers in here that use the same process. So it just runs through each of the different layers: center lines, culverts, topography, the contours, the telco, all the telco nodes, all the street control points. All of those different layers contribute to this final output file geodatabase. And I'm going to make this geoprocessing set of tools publicly available. But just keep in mind, just because you download these tools and plug them in, it doesn't mean they're going to automatically work with your data, especially if your naming conventions are different. That CAD submission standard is the key. So you would have to go in to the model and rework all the queries to match your submission standards. That is the one downside. It's unfortunately not an easy button that I can just press and all this data just spits out nice into a nice file geodatabase. There's going to be a little bit of work to make it work on your end. So what we get is this nice, beautiful scene that I just showed you a little while ago with my trees, with my high tension power lines, with all the underground features, all the above ground features, and a nice visualized environment. All right, so the last thing I want to show you here is this idea of CAD to GIS to CAD. So Utah DOT came to us and said, we really want to give our contractors the ability to go out in the field and mark up or possibly even edit a CAD file. And we looked at them and said, wow, that is a challenging process, primarily because we can't get CAD into ArcGIS Online. So me being one to not turn down any challenge, I took it. And I started investigating workflows, and I found a workflow, and it works pretty well. The workflow is this. You're going to start with a CAD file, and now this I did have to code, but I've made it all configurable. So it's just another GP tool, basically. So it'll interact like any other GP tool, but basically what I do is I take a CAD file, I extract it or export it, or import it rather, to a file geodatabase. And then I've got this template MXD that I merged the file geodatabase to. So I add that file geodatabase I imported from CAD to this MXD, and I create a web map. And all the colors are preserved exactly the way they came from CAD. So I've got layer files set up so that everything matches what it looks like in CAD. And then this creates a web map that I then publish in an automated workflow to ArcGIS Online. So once it's in ArcGIS Online, I have a hosted feature service along with a web map of that CAD file. And that looks something like this. So here's that same exact CAD file in ArcGIS Online as a hosted feature service. So I have a hosted feature service out there that I created, and I built it using this set of tools. So I'll show you the tools. So I have this tool called CAD to Web Map. So if I open this up, it's configurable. So you don't have to know anything about the model or the scripts. You can just input your CAD file, give it a name, give it a spatial reference, tell it what layer files to use, tell it what the MXD is, and it does everything else. It takes care of packaging up the CAD file, creating a file geodatabase, creating the MXD, and then publishing that out to ArcGIS Online. I've taken care of everything. Even logging into ArcGIS Online is handled by this particular tool. So once this data is in ArcGIS Online as a web map, like you see here, I can also view it here in an app that you're probably very familiar with. So this is Collector. And I've got the same exact the same exact CAD file inside of Collector using ArcGIS Online. So I can zoom in. So we're going to zoom into that culvert. I'm going to edit the node. Let's edit the node first. Let's update that. Now I'm going to edit the line. I'm going to drop it. Now, I have to warn you, Collector does not support snapping yet. So, and I told Utah this, I said I would be very wary of allowing people to edit the actual geometry. You would be much better off giving them a red line layer that we could bring back into the CAD file so that the designers can be notified. So this is the main issue, the main crux of the issue that Utah wanted to solve. They need to give their designers or their contractors the ability to edit a CAD file, but they also want their designers to be notified when changes are made, because what's happening now is these contractors are making changes and they're never getting relayed back to the design team so that the CAD file can get modified. And they want to approve changes. So if a contractor just moves a sign just to move it, they want to be able to see that and say, no, you can't do that. But if the contractor said, well, we can't dig the hole here because there's this gigantic boulder and we can't get around it. So then the designer can say, okay, well then move it 5 feet to the north or to the south if the road's running east-west, so that, or move it east-west, depending on where you need to move it to get away from that rock, but still give the sign the visibility it needs to the motorist. So this allows the designers and the contractors to be in better collaboration with one another. But like I said, we don't support snapping, so you probably want to, at the beginning, open this up to redlining at this time. And eventually, we are going to support snapping. It's going to happen in one of the next releases. I'm not sure if it's going to be in June or in the fall, but that is on the list of enhancements to Collector. So when that does happen, I would be able to edit this with confidence that everything is snapped together. Otherwise, right now, if you do want to do editing, you can do it, but you would have to have some geoprocessing on the back end to make sure that this is all post-processed and snapped back together. Then you got to decide what takes the precedence. Is it the node or the line? Long story short, I would recommend that if you're going to do editing, you edit red lines to start until we get to a point where we can reliably do snapping. So now I'm going to update this. And so now I'm going to move Collector out of the way, and if we zoom into my web map, you see that the culvert and the node moved. Everything moved exactly the way I wanted it to. All right, so now the last thing I'm going to do before I take questions is I've got a process. So when I'm done, I have this folder called CAD Updates. It's currently empty. There's nothing in it. I'm going to take this web map to CAD GP task I've built, and I'm going to download that CAD file to DWG R 2010. So I'm going to click OK here, and I'm going to let this run. So unfortunately, for this process to work, I do have to be signed in because we changed our login model. But basically what's happening is I've logged in to ArcGIS Online through Python, and I found that item, that CAD item that I just edited with Collector. And it is in the process right now of running the export function. So if you know anything about ArcGIS Online, you know you can go to any feature service and export it out to a file geodatabase. That's exactly what I'm doing here in an automated process. So I'm exporting out that CAD file, and now it's done. It's downloaded the zip file. So we provide that geodatabase back as a zip file. I unpack the zip file. I rename it to the appropriate CAD name, and then I export it to a DWG. So now what I have, you can see now that this folder has something in it. Now I've got a file geodatabase and the CAD file. Now, I have an issue right now on my PC specifically where it shows all of these layers multiple times. I've got to work, I'm actually getting a new computer in a couple weeks, and I expect this problem, I don't know what the problem is, but I've got a problem. But anyway, I've got lots of problems, but that's besides the point. When we zoom in, you see my CAD file now has the change I just passed in from collector. So I was able to take, and this is where it initially ended, right here inside this green triangle, this outfall area. So I was able to take, through collector, through a process, to upload a DWG or DXF to ArcGIS Online as a feature service, edit that feature service in collector, and then bring those edits back down to the ground in a DWG that my CAD operators can then compare and make the necessary changes they need to make. So if they want to accept this change, they've got everything they need to do so against their original CAD file. So that's the workflow I really wanted to share with you. So to finish up the road ahead, what else is possible? Well, my goal is by user conference to have a process in place to do validation, to find out if a CAD file I'm going to input in is going to be able to, A, be converted to GIS features, and B, can I get it uploaded to ArcGIS Online? So that's the process I want to do next. I want to figure out if it's projected, if it's georeferenced, and I'm pretty sure I can do this all through a combination of Python and Model Builder. I'm going to check to see if the required layers are included, and if not, I want to reject it and report to the end user. So I'm going to make this a geoprocessing service that is going to live on ArcGIS server that someone could take, upload a CAD file to it, and if it fails, they'll get a report back to them saying no, and here's why it didn't. So that's the goal. So to summarize today, I showed you 3 things that really matter when bringing CAD to GIS. The first is location and standards. You've got to have, the CAD files have to be location aware. And we've got to have standards. That's going to ensure that it's easy for me to migrate the data to geodatabase, to GIS. I need a way to access and share this data. So I want to be able to create realistic scenes. I want to collaborate in the field. And I want to use GIS to keep CAD in sync. Finally, I want to develop all of this in a COTS-supported environment. So I chose geoprocessing because ultimately, at the end of the day, all of our tools are supported. So if you want to incorporate these workflows, they're all fully 100% supported because they use the geoprocessing framework. I didn't have to use any third-party things. I'm using Python, I'm using Model Builder, and I'm using Arc Toolbox. And all of these things that I built are fully supported. They're defendable, they're repeatable, and they're all documented. So I thank you all for your time. And I'm going to post these out on the GeoNet. So I don't know if you're familiar, but we have a group on the GeoNet. So if you go into geonet.esri.com and you go to communities, type in departments of transportation, and you will find our group. And this is a public group that any of you can join. So when you get to this group, you'll find on the lower right-hand side under projects, I've got a CAD to GIS integration subgroup. So if you click on this group, you will find the presentation I shared with you today, and then in the next week or so, I'm going to work to get those geoprocessing tools that I used to do all this prototyping and development out there on the GeoNet so you guys can download it and use it in your own workflows. So with that, that's all I have to share today. I thank you very much for your time. And Bob, if you and Janelle, if you want to open the floor to questions, let's do it.
Thank you very much, Eric. That was Eric Rodenberg from Esri's Transportation Solution Team. We have some questions that have been flowing in. Eric pretty much showed us where we might be able to get these answers very soon, but let's just go over some of them. There was you said the geoprocessing models will be available in the weeks to come on the website that's showing up right now.
Yes. And I can share them to MagTug too if that's easy for you guys. I can just share links to everything so you can just reference it right on your website. Awesome.
That would be great. And the more places, the easier it will be for our attendees to get it.
Right.
Someone also did ask if they asked for personal tutorials on this process. Would that be available as a training selection through their local account managers? Would you be able to have a training for a group?
So, you know, this is something we've been kicking around. We're not sure the best way to do this. We've actually kicked around like a jump start, like a 2-day focused jump start through professional services. And it's something that I can talk to Ed Services about as well, Esri Ed Services, to see if they would want to tag on to this and possibly develop a curriculum around this. But right now, I need to have some conversations with a few different folks, and I don't necessarily know that I have a good answer, but I know through the transportation team's professional services practice, we do have a jump start that we can offer, and it's a 2-day jump start where we come on site with one of our guys and we basically deliver these tools to you and show you how to use them and configure them with your own workflows.
Okay. I'm sure there's a lot of people tuned in that will be excited to hear about that possibility.
Yep.
Would it be best for them to contact Jason Seeley if they're in the Mid-Atlantic area? Or
yeah, so yes. So have them contact Jason Seeley or I'm blanking out here. I can't, I can't think of his name. I'm sorry. I'll think of it in a second. But
that's okay. Most people do know Jason Seeley. If you don't have his email address, it's jsealy@esri.com. And just mention that you heard it in today's webinar. And
Seth Van Aken was the other contact.
Okay.
And he's out of the Philadelphia regional office as well.
Okay. One of the attendees also asked if we would get an email link with the presentation and the data model. Unfortunately, no, because it's a sort of an all-volunteer organization. We have a lot of different people helping with different parts of the webinar. So you will get an email that says that you attended this webinar, but the recording will be on the magtug.wordpress.com site in a few days, and of course, Eric also showed us where you could get information on the ESRI GeoNet. So you will be reminded that this information is available, but you will have to navigate to find it, and it will take us some time to get those pieces together. Is there any more questions from the audience that we haven't gone over? I'm trying to see.
I think that's all I see there, Janelle.
Okay.
Let's see. But I would urge the audience, if you have follow-up questions that you come up with later on, we can certainly get them to Eric. and get them addressed for you.
Yeah, and we have actually hit the 11 o'clock, so I don't want people to be late for their next important meeting, so we will cut it there. I just hope that you all enjoyed the webinar today and will join us on May 24th for our next installment, which is going to be a talk on GIS-based local agency permit management systems. Thank you very much, and have a good day.
Thanks again. Thanks, Eric. Bye-bye.